So welcome to all of you. Now we will see how to find the angle between line and a plane. So the problem is that find the angle between the line. Line is given in the symmetrical form. If it is not in symmetrical form, then we need only the direction ratio of the line. Okay. So and the plane. Okay. So equation of line and equation of plane are provided to you. You have to find the angle between the line and plane. Okay. So now this is a plane now. This is a plane, okay, and this is a line. And what is this? So suppose this is the angle theta, angle between the line and plane. Okay, so let theta be the angle between line and plane, Okay, so this is the line which is normal to the plane. This is what N, it is the normal to the plane. Okay, so I will call this as a P and I will call this as a Q. Okay, Q, and this is O now. Suppose O is the origin. Okay, so then theta is the angle between line and plane. Okay, so this is what then, this is what 90 minus theta now. This is 90 minus theta. Okay, so Pn is normal to the plane. Normal to the plane. DRS of PNR. DRS of PNR. What is PN? PN is normal to the plane. What is the equation of the plane? AX plus BY plus CZ plus D. The coefficients of X, Y, Z represent the DRS of the normal to the plane. So R, this is DRS of PNR ABC, and DRS of the given line R A1 B1 C1, R A1 B1 C1. Okay, so now we have the DRS of this one, then angle between line and normal to the plane is 90 minus theta. Okay, so therefore cos 90 minus theta is equal to what? A1 plus B1 plus C1 upon root of A square plus B square plus C square into A1 square plus B1 square plus C1 square. This is the formula. Okay, so cos theta, but cos 90 minus theta is sin theta. Okay, so this is what? Sin theta is equal to AA1 plus B1 plus C1 upon root of A square plus B square plus C square into root of A1 square plus B1 square plus C1 square. So angle between line and angle between two lines is nothing but cos theta, but angle between line and plane is nothing but what? Sin theta. Only this is the difference. What? Instead of cos theta there is a sin theta. So we are using the direction ratio of the normal to the plane and the line only. Okay. So this is the difference. Okay, angle between plane and angle between the line is cos theta. Angle, if you want to find, that means angle between the two plane is also cos theta. Angle between the two line is also cos theta. But angle between line and plane is nothing but sin theta. Okay. So remember this as the formula. We'll take a problem on it. Find the angle between the line 3x minus y plus 2z is equal to 1, minus 1 is equal to 0, is equal to x plus twice y plus twice z minus 5, and the plane x plus y plus 11z is equal to 1. Okay, solution. So what we want to find the line. Line is not in the symmetrical form. Line is not in a symmetrical form. To find the angle between line and plane, what we need? We need the direction ratios of the line and direction ratios of the normal to the plane. Okay. So you have the equation of the plane. That means you have the direction ratios of the normal to the plane. But we don't have the direction ratios of the line, because line is not in the symmetrical form. So what we'll do? We'll find the direction ratios of the line. Okay. So let A, B, C be the DRS of the line. This line, just will write this: a 3x minus y plus twice z minus 1 is equal to 0 is equal to x plus twice y plus twice z minus 5. I will call this as 1. Okay, line 1. Okay, so therefore we have 3a minus b plus twice z. Forget about the constant only. Okay, so replace x, y, z as a, b, c only. So this is what a plus twice b plus twice c is equal to 0. Okay, so this is a upon minus coefficients of b, coefficients of c. This is minus b upon coefficients of a, then coefficients of c, then c upon coefficients of a and coefficients of b. Okay, so a upon minus 2 minus 4 minus 6. So minus b upon minus 6 minus plus 6, 6 minus 2, so this is 4. C upon this is what 6 plus 1, 6 plus 1 is 7. Okay, so therefore DRS of line 1 are 6, 4 minus 7. Okay, so these are two negative. I will take only one negative. I will change the sign of all. Okay, if you change the sign of all, or if you can multiply by a constant number, then it doesn't matter for this. Okay, your DRS will be the same now here. They are proportional actually. Okay, so DRS of normal to the plane, x plus y plus 11z is equal to 1 r 1 1 1 1 11 1 1 11. Okay, let theta be the angle between line and plane. So therefore sin theta is equal to sin theta. You have the DRS. Just take the product of this one. What? 6 into 1 plus 4 into 1 plus minus 7 into 11 upon root of 6 square plus 4 square plus minus 7 square root of 1 square plus 11 square plus 11 square. Okay, so what we'll do, we'll take this negative, so that angle becomes positive now. This is minus. I'll take this. Okay, we'll take this as positive. No problem for this one. Okay, so that angle becomes positive now. No problem for it is negative. No problem. Okay, you can write as it is now. Okay, so sin theta is equal to, so minus 6 minus 4 plus 77 upon root of, so this is what 36 plus 16 plus 49, 1 plus 1 plus 121. Okay, so now this is minus 10, so 67 upon root of, so this is what 6 plus 6 is 12, 12 plus 9 is 21, so 1, so 6, 7, 10, and this is 120, 3. This is 123. Okay, so this is sine theta. So theta is equal to, you have what angle, so this is what 67 upon root of 101 into 123. Okay, so if you don't want to write, this is what minus minus. Okay, so this will be what then minus 67 upon this one. Okay, no problem for this one, you can write this. Show that the line x minus 2 upon 6, y minus 3 upon 4 is equal to z minus 4 upon 5 is parallel to the plane, twice x plus y minus twice z is equal to 3. Okay, solution. DRS of the line x minus 2 upon 6, y minus 3 upon 4, z minus 4 upon 5 are 6, 4, 5. Okay, DRS of the normal to the plane, so twice x plus y minus twice z is equal to 3 are 2, 1 minus 2. Okay, so now what we have to prove, the line is parallel to, see, this is the line and this is the plane. So what we have to prove, the line is parallel to the plane. So now this is the normal to the plane. You have the DRS of the normal to the plane. So if you prove that the normal is the perpendicular to this line, then this line is the parallel to this one. Okay, so just you have to do this product is what 6 into 2 plus 4 into 1 plus 5 into minus 2 is equal to, this is 12 plus 4 minus 10. So something is wrong here. 6, 4, 5 and the plane is 2, 1 minus 2. Okay, so this will take 3 now. So this will be 3. So this will what 6 then. So printing mistake is there. This is 3. We take 3. So this is what 3 now. Okay. So we'll correct the problem. So that is 3. Now this is what then. This is 0. Okay. So therefore the line is parallel to plane. Parallel to the plane. Okay. So we'll write a note. The line the line x minus x1 upon a, y minus y1 upon b is equal to z1 minus z1 upon c is parallel to the plane, a1x plus b1y plus c1z plus d or d1 doesn't matter because d is not twice. Okay, so abc are there, therefore we are writing a1 b1 c1. Okay, if parallel to plane, if and only if a1 plus b1 plus c1 is equal to 0. So this is the formula, line is parallel to the plane. Okay, so actually this is what line is parallel to plane means, line is perpendicular to the normal of the plane. Okay, so that is the line is perpendicular to the normal of the plane. Okay, find angle between the line x minus 1 upon 2, y minus 2 upon 1, z minus 3 upon minus 2 and the plane x plus twice y plus z is equal to 3. Okay, solution. DRS of the line x minus 1 upon 2, y minus 2 upon 1, z minus 3 upon minus 2, r 2, 1, minus 2. Okay. So drs of the normal to the plane, x plus twice y plus z is equal to 3, r 1, 2, 1. Okay. So let theta be the angle between line and plane. So therefore sin theta is equal to, we have to write sin theta because we are finding the line. This is not angle between two lines or angle between the plane, so it is sin theta. Okay. So just we have to take the dot product. So 2 into 1 plus 1 into 2 plus minus 2 into 1 upon the sum of the squares of the direction ratios. So this is 2 square plus 1 square plus minus 2 square into 1 square plus 2 square plus 1 square. Okay. So these 2 get cancelled. So this is what 2 now upon. So what is this? This is 4 plus 4, 8 plus 1. So this is what 3 into root of 6. So theta is equal to what? Sin inverse of 2 upon 3 root 6. Find the equation of the plane through the points 1, 0, minus 1, 3, 2, 2 and parallel to the line x minus 1 upon 1, 1 minus y upon 2, z minus 2 upon 3. Okay, solutions. So we have to find equation of plane now, not the equation of line. So you can use one point here. Okay, the equation of the plane, passing through a 1, 0, minus 1 is of the form. One point is of the form. You have to use this. Okay. So a into x minus 1 plus b into y minus 0 plus c into z minus 1 is equal to 0. This is 1. Okay. You need to find a, b, c. Okay. Okay. So plane 1 passing through b 3, 2, 2. Therefore, so we have. Okay. So that means what this 3, 2, 2 satisfy the equation 1. Okay. So this is what, just I write this. What 3 minus 1. So this is twice a. Okay. So plus twice b because 2 minus 0 plus 2 plus 1 3c is equal to 0. You got one relation of a, b, c, right? So there is no constant term. You want a second relation of a, b, c. What is the condition? Is what the plane 1 is parallel to. Okay, the plane 1 is parallel to the line x minus 1 upon 1 or 1 minus y upon 2 is equal to z minus 2 upon 3. Okay. So that is, you have to rearrange this because you want y minus 1. Okay. So that is what? That is x minus 1 upon 1, y minus 1 upon minus 2, z minus 2 upon 3. You have to take the care because what? Here DRX will be what? 1, 2, 3 not. 1 minus 2, 3. Okay. So therefore we have so DRS of the normal to the plane 1 are what? A, B, C, and DRS of the line are what? 1 minus 2. So their dot product is 0. So therefore what? So A minus twice B plus 3C is equal to 0. This is your 3 now. This is your 3. Okay. You need to find A, B, C now. You need to find A, B, C. Okay. So this is what? A upon what? Coefficients of B 2 minus 2. Coefficients of C 3, 3. Okay. Minus B upon coefficients of A 2, 1. Then coefficients of C is what? 3, 3. Then C upon coefficients of A 2, 1. Coefficients of 2, 1. Coefficients of B 2 minus 2. 2 minus 2. Okay. So A upon, so this is what? 6 minus 6. 6 minus 6 is 0. 6 minus 6 is 0. Oh, what? 6 minus 6? This is what? Plus now. This is 12 now. This is what? 12. This is 12. Okay. Minus B upon 6 minus 3 is 3. C upon minus 4 minus 2. Minus 4 minus 2 is minus 6. Okay. So put A is equal to 12, B is equal to minus 3, C is equal to minus 6. In 1 we get, these are not actual values of this, they are the proportional. Actually I have to write A is equal to 12k because this is equal to k. A is equal to 12k, B is equal to this. But if you put kk here, so k get cancelled, so therefore we are not fitting that A is equal to this. Okay, so we can put this A is equal to, these are not values of A, B, C, are actual values of this. This may, they are proportional to this one. Okay, so you may write this one: A is equal to 12k, B is equal to minus 3k, C is equal to minus 6k. Yeah, you can put here now. Okay, so this is what then 12 x minus 1 minus 3 y. Okay, so minus 6 z plus 1 is equal to 0. So this is what? 12x minus 3y minus 6z. Okay, so this is what? Minus 12 minus 6, so minus 18 is equal to 0. So all are divisible by 3. So this is what? 4x minus y minus twice z minus 6 is equal to 0. So this is the required equation of the plane. This is the required equation of the plane. Next, find the equation of the line through the point minus 2, 3, 4 and parallel to the planes twice x plus 3y plus 4z is equal to 5 and 3x plus 4y plus 5z is equal to 6. Okay, solution. Let the equations, find the equations of line. Equations of a line equation, let the equation of the line through the point -2, 3, 4 b x plus 2 upon a, y minus 3 upon b, z minus 4 upon c. I call this as 1. This is your required line. If you get the value of a, b, c. So what is our aim? To find the values of a, b, c. What is given? The line 1 is parallel to the plane. Okay, line 1 is parallel to the planes, twice x plus 3y plus 4z is equal to 5, and 3x plus 4y plus 4 is equal to 6. Therefore we have, so DRS of normal to the plane are 2, 3, 4, and DRS of the normal to this plane are this. Line is parallel to this plane. That means it is perpendicular to the normal to the plane. So that means what we have, just replace the x, y, z as a, b, c, forget the constant. So therefore we have twice a plus 3b plus 4c is equal to 0. So 3a plus 4b plus 5c is equal to 0. So a upon 3, 4. Coefficients of b, coefficients of c minus b, coefficients of a, coefficients of c, then c upon, here you have to write the minus. Okay, so coefficients of a, coefficients of b. Okay, so a upon, so this is what, 15 minus 16, so this is minus 1, minus b upon, this is 10 minus 12, 10 minus 12 is minus 2, c upon 8 minus 9, this is minus 1. Okay, so I can write this is a upon 1, this is what, b upon minus 2. I am changing the sign of all now. Okay, c upon minus 1. Actually what here, a upon minus 1, b upon 2, c upon minus 1. Okay, I will change the value. Okay, put a is equal to, put a is equal to 1, b is equal to minus 2, and c is equal to minus 1. In 1 we get x plus 2 upon 1, y minus 3 upon minus 2, z minus 4 upon, this is plus 1 upon 1. Okay, so this is the required equation of the line. This is the required equation of the line. Okay, so this is the required equation of the line, Okay, so the problem is over now. So what we are using, the line is parallel to the plane. Because line is parallel to the plane, then what, dot product of the direction ratios is 0. Okay, show that the equation of the plane parallel to the join of 3, 2, minus 5 and 0, minus 4, minus 11 and passing through the points, minus 2, 1, minus 3 and 4, 3, 3 is 4x plus 3y minus 5z is equal to 10. You want to prove that. This is your required equation of the plane. Okay, solution. What you want? Find the equation of plane parallel to, okay, so that we will see later on. Passing through the points, these 2 points, you have to find equation of planes passing through these 2 points and parallel to the line joining these 2 points. Okay, Okay, so first we will use these 2 points first. Okay, let the equation of the plane through a minus 2 1 minus 3 b a into x plus 2 plus b into y minus 1 plus c into z plus 3 is equal to 0. This is your required equation of the plane. If you get the value of a, b, c, now your aim is to find the values of a, b, c. Values of a, b, c. One more condition is given that your plane 1 passing through 4, 3, 3. Okay, so plane 1 passing through B, we will call this as B, 4, 3, 3. Therefore, we have, so this 4, 3, 3 satisfy the equation 1. So I directly put this is what 4 plus 2 is what 6a. This is 6a. So 3 minus 1 is 2. So this is twice B. Okay, 3 plus 3 is 6. So 6c is equal to 0. So it is simplified. You can simplify this. This is what 3a plus b plus 3c is equal to 0. I call this as 2 now. I will call this as one relation you got in terms of ABC. You want to find other relations. Okay, so that we will find. Okay, so DRS of join of we will call this as P now. So 3 to minus 5 and Q 0 minus 4 minus 11 R. So what 0 minus 3 minus 4 minus 2 minus 11 plus 5, that is minus 3 minus 6 minus 6 that is you can divide by minus 3. So what we get then 1 2 2. So DRS of the line joining PQR 1 2 2. That's the proportional, no problem for it. You can divide by 3. If it is divisible by, then you can divide by this. Okay. So but what plane 1 is parallel to PQ. So we have your plane parallel to this PQ. So that means what again the product is 0 now. This is what A plus twice B plus twice C is equal to 0. Okay. So we can write the values of A and B now. A of 1. Okay. So I write the values here now. What is that? 3A plus B plus 3C is equal to 0. And your equation what? A plus twice B plus twice C is equal to 0. So A upon what? 1 2 1 2 3 2 minus B upon, this is minus B. Okay, minus B upon coefficients of A 3 1, coefficients of C 3 2, this is C upon 3 1 1 2. Okay, so that is what A upon. I want to put the value of A here now, A B C. Okay, so A upon what? 2 minus 6. 2 minus 6. 2 minus 6 is minus 4. Minus B upon. So this is what? 6 minus 3. 6 minus 3 is 3. And C upon 6 minus 1. This is 5. 6 minus 1 is 5. Okay. Put A is equal to minus 4. B is equal to 3. Minus 3. B is equal to minus 3. And C is equal to 5. In 1 we get. Okay. So we put here now. What is your A now? A is minus 4. Just highlighting here minus 4. Okay. What is your B? B is minus 3. B is what? Minus 3. And what is C? C is 5. This is equal to 0. Okay. So what you want? Equation 4x plus 3y. Okay. That will exist now. Minus 4x minus 3y plus 5z. These are your coefficients of x, y, z. We will collect the constant now. This is what? Minus 8 now. This is what? Minus 8. Minus minus become plus. So this is plus 3. And this is 15 now. Plus 15. So 18. So this is what is plus 10. Plus 10 is good. You have to change the sign of all. 4x plus 3y minus 5z minus 10 is equal to 0. Okay. So you can shift 10 to this side. So this is what therefore 4x plus 3y minus 5z is equal to 10. See, we get the required equation of the plane. I hope that you understand this one. Okay, so these are the problems related with the angle between the plane and the line. Okay, so here we are using that the line is parallel to the plane. Okay, so parallel to the plane means angle between the normal and the line is 90 degrees. Okay, that we are using here. Okay, so we'll stop here.